Hello everyone, my name is Yatish and today I'm gonna talk about nonlinear amplifier. I'm doing my bachelor's in computer science, hence in BIT. So what's a nonlinear amplifier? Before that, we have to know what's an amplifier. An amplifier is an electronic device or a circuit which is used to increase the magnitude of signal applied to its input. So it's a device that is used to increase the sound. And there are three types of amplifier: voltage amplifiers, amplifiers, and power amplifiers. So as the name suggests, voltage amplifier is an amplifier that increases the input voltage and produces more voltage at the output. And a current amplifier is an amplifier that increases the input current and produces more output. And a power amplifier is the is an amplifier that increases the magnitude of power. Uh, so so these are the three types of amplifiers. Now we are gonna learn more about power amplifier. The purpose of a power amplifier is to increase the power. As the name suggests, it amplifies the power. That is, the product of output voltage and the current is greater than that of the product of input voltage and current. So if either the voltage or the current at the output may be less than the input, but all the overall current and voltage product will always be greater than the input. So it amplifies the power of an power. Always a power amplifier always amplifies the power. So when an AC signal is applied, it only amplifies a part of it. Not it, the an AC signal is always does not stay constant. So it can only amplify a part of it. So there are like 10 types of amplifiers. There are audio frequency amplifier, an intermediate frequency amplifier, radio frequency amplifier, ultrasonic amplifiers, wideband amplifiers, direct coupled amplifiers, video amplifiers, buffer amplifiers, transistor amplifiers, operational amplifiers. So these are the types of amplifiers, and the power amplifiers are also classified into many classes like A, B, and C, and we're gonna deal with it later. But now let us learn more about operational amplifier. So an operational amplifier has two input pins and one output pin. Its role is to just amplify the output voltage difference between the two input pins. So you can see in the PPT the symbol of the operational amplifier. You can see there's two inputs V1 and V2. So there's an voltage difference between V1 and V2. The the work of an op amp, it's short form for operational amplifier. The basic role of an op amp is to increase the voltage difference between the V1 and V2 and give a more output voltage V out. So this is the circuit diagram, and the normally used op amp is as shown in the figure there. So the on basis of an operation, there are two types of op amps: linear and non-linear. So linear amplifier is an electronic circuit whose output is proportional to its input, but capable of delivering more power into the load. So in a linear amplifier, the circuit is output is proportional to its input. So when you plot this linear amplifier output to input graph, there's a straight line. There's a straight line. Then there's no curve. Like like you can see here in this graph. So you can see in the linear region, there's always a straight line there. This is the role of a linear amplifier. It obeys all laws, and it graph is always a straight line, does not have curve. It Yeah, that's what it produces a signal that are accurate to the copies of input. Like it always produce. You can see in this picture that the linear amplifier always the input is equal to output, but there's an increase in the amplitude. So linear amplifier is a circuit that produces more load, but its output is proportional to the input. So this is a type of a linear amplifier, and this you can see this is a graph that is shown in CRO. So the input the output graph is same as input, but it is increased in amplitude. That is the role of an amplifier. So linear amplifier is always has a straight line in the graph. Now, to our main topic, what is a nonlinear amplifier? So, nonlinear amplifier in a circuit is which gives nonlinear relationship between its input and output signals. So, what is nonlinearity? Nonlinearity is a behavior in circuit, particularly an amplifier, in which the output signal strength do not vary in direct proportion to an input signal strength. So, what does this mean? This means that when you plot a graph in V out when you plot a graph between output voltages and input voltages, or power input versus power output, you can see that the graph deviates from the straight line. It's not a straight line. It deviates from it, so it does not obey every law, and so it deviates from the graph. So you can see that linear region is a straight line, and non-linear region bends away from the output. It's not a straight line, it always bends. So this is the non-linearity, and an amplifier, a non-linear amplifier is that amplifier which does not which in which the input output is not proportional to the input. So in which the nonlinear relationship between input output signal, the nonlinear amplification can be achieved in a simple way by just connecting a nonlinear device, PN junction diode. So you can see there's a diode connected to a this is an op amp. So there's from A node, PN junction diode is connected, and it's connected towards the output. And there's a voltage and resistor, and current flows through A, and yeah, so you can see that in the diagram. So a large change in input voltage. So in a nonlinear amplifier, the large change in input voltage causes small change in the output voltage. So that is why the circuit is also a log amplifier. Hence, the output voltage is logarithmic of input voltage. Further, you will know we will get to see the proof of this. The voltage, the output voltage is logarithmic of input voltage. Uh, a large, yeah. So to the next slide. The previous figure shows us a nonlinear amplifier whose diode is D and uses a negative path feedback. By virtual ground, so we are going to prove that the output is logarithmic of input starting by virtual ground concept, as the node B is grounded, so it's grounded. B is connected to the earth, so node A will also be virtually grounded by concept of virtual ground. Therefore, voltage at node A is equal to zero, as voltage at node B is also zero. So we have the total current equals input voltage minus the voltage at node A. Voltage at node A. So as the voltage at node A is zero due to previous reason, so the total current will be V input by R. let the current IF flow through the diode. So you can see in the figure IF is flowing through the diode. The voltage across the diode is VA minus V naught. Since VA is zero equals zero, the voltage across diode is minus V naught. So the diode equation is seen here, minus V naught because you can see the equation. So where VT is the voltage equivalent of temperature, IF is the diode for a forward current, and IR is the diode reverse saturation current. So nu is the constant constant. So since current through op amp is negligible because it has infinite ideal op amp has a more resistance, so it's negligible. So I equals IF, IF current forward current, diode forward current. So therefore, IF equals I equals voltage input by R. So when you substitute IF in substitute IF in diode equation, we get V naught equals nu Vt ln Vn by IR into R. So IR into R is voltage reference. So and it is a constant. It's always a constant. So nu it is where the voltage, the diode voltage is V naught equals nu Vt ln V input by V reference. So the above equation shows that the output voltage is a logarithmic sum of input voltage. The see here's a graph of nonlinear amplifier as shown before. The linear region is here and it deviates. It goes. There's a curve in the graph, so it obeys non. It goes towards nonlinear region. Yeah. So this is the graph of nonlinear amplifier. Now we'll move on to the differences between linear amplifier and non-linear amplifier. So definition like states that in a linear amplifier, the electronic circuit, the output is proportional to the input of a device while providing additional power to the load. An amplifier in nonlinear amplifier is an amplifier in which change in input does not produce a proportional change in output. In a linear amplifier, the input as you increase the input voltage, the output voltage is way more than input voltage. For a small amount of input, there is more output. So in a non-linear amplifier, the input in the more the input the for a small amount for a large amount of input voltage, only small amount of output is given. So now example. So in a linear amplifier, the in a linear amplifier, you can see that in a graph that produces signals that are accurate to the copies of input. So see, you can see that when you apply a linear amplifier, it is the same but with an increased amplitude. So in a non-linear amplifier, you can see that there's distortion in the graph and it is not proportional. So example of amplification, it's used in non-inverting and non-inverting amplifiers, voltage followers, anti-log amplifiers, and etc. Zero crossing detectors and other Schmitt triggers and multivibrators. So a nonlinear amplifier is also used in AC bridge circuit and it finds many application in other devices also. So this ends my topic here. So thank you.